As we know, sulfonation is another example for electrophilic substitution reaction. In case of nitration, nitronium ion is the electrophile form. In sulfonation, sulfonium ion is the electrophile utilized for sulfonation. The source of this electrophile is that we can use either fuming sulfuric acid or concentrated sulfuric acid. Benzene reacts in the presence of concentrated sulfuric acid when it is heated to give rise to benzene sulfonic acid, and byproduct is water. This reaction is called as sulfonation reaction. Now let us discuss how this reaction occurs in a stepwise manner. That is the mechanism of reaction. Sulfuric acid, as we know, it is a proton donor. It dissociates into H plus and HSO4 minus. This proton which is formed, it acts as a proton donor and it reacts with sulfuric acid. This is the structural formula of sulfuric acid. This has lone pair of electrons and the oxygen. It reacts with H plus. This is electron deficient species and this is electron rich species. Always unlike poles attract each other. The electrons attaches to the H plus and protonation of sulfuric acid takes place. Oxygen valency, as we know, it is 2, but it is bonded with 2 hydrogens and 1 sulfur has become 3. That's why it has become electron deficient center. To satisfy this positive center, the bond between sulfur and oxygen break, the electrons moves towards the oxygen to give rise to SO3H and water. What electrons are taken away from water, that's why it has become positive center. To satisfy this positive center, the OH bond breaks and these electrons are utilized to form SO3, the electrophile which we are in need, along with the H plus. This is the rate limiting step. Formation of electrophile is the rate limiting step. The sulfur trioxide, that is the sulfonium ion which is formed, again reacts with benzene in the fashion how the nitronium reacted with benzene. Benzene, in the presence of sulfur trioxide, an electrophile, the pi electrons moves towards one carbon and a temporary polarization occurs in the benzene ring system. This temporary polarization that occurs in the ring system or any multiple bond system in the presence of an electrophile is called as electromeric effect. As these electrons are moved towards one carbon, the another carbon which is adjacent to it has become electron deficient. This is electron rich carbon and sulfur is electron deficient because it is flanked between all 3 electronegative oxygen. This electrons attacks the sulfur. It has to maintain its valency. Pi electrons moves on to the oxygen and it forms SO3 minus, gets attached to the benzene ring system. To satisfy this positive center which is formed over here, the pi electrons from the adjacent carbon moves and it gives rise to a new carbocation in which the positive center is on the adjacent carbon from which the electrons are moved. To satisfy this positive center, the electrons from the adjacent carbon moves and another new carbocation is formed at the new position. The carbon-hydrogen bond breaks. These electrons are utilized to satisfy this positive center and it gives rise to benzene sulfonate ion along with the liberation of hydrogen as a proton. This is step 3. SO3 minus is unstable. This reacts with H plus. This is electron deficient, this is electron rich. Unlike poles attract each other, bond formation occurs to give rise to benzene sulfonic acid. This is the last step in the reaction process. Sulfonium ion is different from the nitronium ion which is formed in the nitration reaction. Nitronium ion which is formed is an electrophile which has a positive center on it. This is electron deficient like nitronium ion, but here it does not have any positive center. This is a neutral electrophile. This is the beauty of sulfur trioxide or sulfonium ions. Sulfonation occurs at very fast pace when we heat it at 40 to 50 degrees centigrade. This is how the sulfonation occurs in benzene. Thank you.